Alright, well, welcome to lesson 19's portion of the project. So take a look at the streets in Phoenix. North 9th Avenue, North 10th Avenue, North 11th Avenue, North 12th Avenue, and North 13th Avenue are parallel, and they intersect West Roosevelt Street and Phoenix-Wickenburg Highway. The distance between North 15th Avenue and North 13th Avenue, represented by segment AB, so this is 15th Avenue. So A to B is 530 feet along Roosevelt Street. The distances between North 13th Avenue and North 12th Avenue, segment BC, between North 12th Avenue and North 11th Avenue, segment CD, between North 11th Avenue and North 10th Avenue, segment B to E, and between North 10th Avenue and North 9th Avenue, segment EF. And that is my son in the background doing an awing, if you can hear him. They are all the same. They are 350 feet. Now let's find some distances between these avenues along Phoenix-Wickenburg Highway. So they want to find them along this one. So if the distance on Phoenix-Wickenburg Highway between 13th Avenue and 11th Avenue, represented by GJ, is approximately 1,060 feet, how long is Phoenix-Wickenburg Highway between 13th Avenue and 15th Avenue, segment AG, the nearest foot? So we need to, our options are 530 feet, 826 feet, 340 feet, or 1,652 feet. So if we look at this, notice we have some triangles. We have A, B, G, which includes the side length that they want. They want the side length AG. So if we were to draw out ABG, I'm going to draw it right here. ABG. I'm going to use X to represent that's what we want. And we know A to B is 530 feet. Alright, then they give us this G to J portion, and it is part of a side leg of a triangle. So if I were to recreate this triangle again, right here, we would have a larger triangle along those two avenues, those two, and it's at point A, point B, point J. And the way we can find AD's total length would be to total up all of these. Now if you notice, they only give us a portion of A to J. Sorry, he's really talkative right now. Which goes from point G to point B. So this length they gave us was 1,060. So there's our two triangles that would be similar. And we want to be able to find the length A to G. Now, since these are streets, they're going to be parallel. So we have side length BG parallel to side length DJ. And in one triangle, if we have a side length that is parallel to another side length, it's going to split the two sides that it's touching proportionally. So that means that it split AB and compared to BG proportionally, and AG compared to DJ proportionally. So if you notice this one in our original diagram, say I took this great big triangle right here, and if you notice, each of these is parallel. Well, BG, if we said for argument's sake, that each of these lines cut it a quarter, that means that this distance would be a quarter of AF, and this distance would be a quarter of A to L. And then if we were to say, okay, what would it be to here? So then this distance, let's say 2/4, would be 2/4 of AF, and this distance would have to be 2/4 of our total. Or we could compare each segment, a quarter to a quarter and a quarter to a quarter. So there's two ways to look at this proportionality. We could compare the proportions to each, the side length, or to the side length of the opposite side. So we're going to, I find it easiest to set up ratios comparing the same side length to itself. So when we're going to use this triangle to set it up, and this segment was X, this segment was 530, and this segment is B to D, which is 340 plus 340, so that's 680. So we can compare side length to side length, and since AG is what I'm looking for, I want to start with that. So I have AG can compare to GJ. That ratio is going to be the same as AB is to BB. Then I'm going to use the substitution to fill in what we don't have. The other ratio we could set up is comparing the side lengths to each other. So we could say AG, ratio of AG compared to AB. So now I'm going to cross AG compared to AB would be the same as GJ to BD. Okay, so there's at least two ratios. There's many other ratios we could do, but those are the two that are standing out to me. I'm just going to use this first ratio set up to solve. So AG by substitution, we said, is just going to equal our X. GJ by substitution is 1060. That's going to equal. AB by substitution, its length is 530. And the length of BD by substitution is 680. Okay, now we need to solve for x. Now, x is being divided by 1060, so I'm going to multiply 1060, which is our multiplicative property of equality. I'm going to do it to both sides. So 1060 times x is x. 1060x divided by 1060. That's going to equal, I'm going to type that into my calculator. And right here. So I'm going to type in parentheses 530 divided by 680 times 1060. And the reason why I can type it into my calculator is because all of these are numbers. So that gives me 826.17. 826.17. 826.17. Now, 1060x divided by 1060, these reduce down. 1060 divided by 1060 is 1. So I have 1x equals 826.17. And in math, it is by tradition, I guess, that we write 1x most often as just x. So we have x equals 826.17, which we found the length of it. So the length from A to G, or from 15th Avenue to 13th Avenue along Phoenix-Wickenburg Highway, is 826.17 feet. Now it says to round it to the nearest foot. Since this 10th place is a 1, that means it's closer to 826 feet than it is to 827 feet. So we would keep it at 826 feet. Okay. So now, refer to the previous question. What is the correct way to set up the proportions to find the distance asked in the previous question? What is the reasoning behind your proportion? There is more than one correct answer choice for this question. Okay, well, I'm just going to look for one that looks like the one we set up. So we have x over 1060 is equal to 530 divided by 680. And if we had set up this one using our substitution, we would have, right here, we would have AG, which was our x. AG was our x, divided by AB's length was 530. That's going to equal GJ, which was 1060, divided by BD is 680. So let's see if they have that option as well. So they have x over 340, x over 680 equals 530 over 1060. And then they have x over 1060 is equal to 530 divided by 340. No. So let's check out these. 530 is comparing AB to DJ, which we cannot do. What was our reasoning? The triangle proportionality theorem. That's where if you have a parallel side here, if you have a parallel side versus, then it cuts the triangle into proportions. And then question 3, how long in feet is Phoenix-Wickenburg Highway between 9th Avenue and 11th Avenue? Segment JL. So segment JL, they want us to find. And so we can do that by, we want to find JL. So we're using this whole big triangle now. And they want to find from J to L. So they want us to find this length. And we know this length. And I do know this length right here. So I'm just going to use my sections. So now I'm going to use this section. So this section is 340 and 340, which is 680. This section is 340 and 340, which is 680. Since they're both the same length and we know that it splits it proportionally, that means that this length, since this is 1,060 feet, this has to be 1,060 feet. So it is 1,060 feet. Refer to the previous question. Which of the following proportions would help you find the distance asked in the previous question? Select all of the proportions that can be set up to find the distance. If only one proportion can be written, select it, and also select the answer choice only. Okay, so GJJL. GJJL. Okay, I've got to write those down. G to J, J to L is equal to AC over CF. Alright, let's see. G to J right here compared to JL has to equal A to C and C to F. No, because A to C includes a portion that is not included in our G to J. If we were going to go all the way to point A, we would have to go all the way to point A on this side as well. So that one's not. AJ. He just has a lot to say. JL equals AD compared to DF. Okay, so A to J. They're using a long segment. A to J compared to JL and A to D. It better stop. That other proportion better be right, that distance. Yep. So A to D and then D to F. So that one would work because they both are cutting off, they're both AD and AJ both end at the line that's parallel to F L. So that one would work. Now let's compare the last one, AGGL. Compared to AB to BF. Alright. So now we have A to G. So A to C being compared to G to L. And A to B, since it stopped on that parallel line, A to B being compared from B to F. So yes, because they both terminate on the parallel line. Alright. Now find some examples of real-world triangles in a similar way and find the approximate distances using the triangle proportionality theorem. So I would grab Google and type in real-world example of triangle proportionality. That one. And you'll notice it brings up images. So then this one would be a great one. You notice that diagram and this one are basically the same. This one just has a mountain on it. So I would copy this, copy image address, paste it in. Oops. Maybe I can just copy the image and paste it. Okay, well, this is the first. So if I copy that, will it? Okay, so I had to click on it and pull it up there. And then I click copy image address. And so I'll step through how I got that to work again. So I clicked on my picture, brought it up here, right click, copy image address, and then I pasted using Ctrl V, Control V. And then now I would say, okay, well, the distance from the base of the mountain to Woo Village can be found by using the ratio quality of, I'm going to say base to Woo Village compared to Woo Village to the top, and base to Roo Village compared to Roo Village to the top. So, base to Roo Village compared to Woo Village to the top. And the ratio of base to Roo Village compared to Roo the top. So base to woo divided by woo to the top would equal base to roo divided by roo to the top. So that's how I would find this little missing part. And it would, then I would save this, save and exit it, and then you'll be ready to do the next portion of the project in lesson 19. And so I want a different picture instead of this one, and I want you, and not the diagram right here either. So I want you to find a different picture and explain how you would find the missing piece of the sides